Hello everyone and welcome to Handmade Hero Show, where we code a complete game live on stream. We are in a lighting mood today. We actually have a lot of lighting stuff done at this point, but we have to debug because we're sort of cranking down on finishing the lighting system. And at the end of the last lighting stream, we did some changes to how we were going to store lighting over time, and we did not have a chance to debug them. So our lighting needs to be sort of cleaned up and debugged. That's what we have to do today. And yeah, I will go ahead and get right to it because it's going to take a while because lighting is complicated. Okay. Let me just go ahead and show you what I'm talking about here, because you may not remember or you may have missed last week's Sunday episode where we did this. The basic problem that we have to solve is that lighting is difficult business. So just showing you what's going on here. This, I believe, is debug mode. Let me just make sure. Yeah. So this is a debug mode build, so it's very slow at the moment. But what's going on here is you can see just like pure chaos happening with our lighting. It's completely bugged out. It's not supposed to be doing this weird disco effect or anything like this. It was working just fine before, but then we changed how the storage stuff was working, and now we've broken everything. So our goal obviously is to unbreak things, as you might imagine. So we're going to go ahead and work on that today. Now, what is it that we broke and why did we break it? I'll just kind of go over that really quickly on the blackboard. I want to say whiteboard because it's clearly a blackboard at this point. Let's get the day number in here. Day 426. Lighting. Storage. So, lighting is too expensive. It's not that we don't know how to compute lighting. We do, right? In computer graphics, we know how to compute lighting now. We're actually pretty good at it. And if you want to spend an hour's worth of computing time on a compute farm somewhere that spins up hundreds of cores, you can do even incredibly complicated scenes with incredibly detailed lighting and get very, very realistic computations out the other end. So it's not a question of not knowing how to do perfect lighting. We kind of do. What we don't know how to do is do perfect lighting quickly. In fact, we don't even know if it's possible to do perfect lighting quickly. It may just not be with today's horsepower. So what we have to do is we have to figure out ways of getting lighting that's usable and interesting in our game, and that looks somewhat accurate so that it feels believable and usable, but that obviously isn't really a real lighting solution, because we just kind of know ahead of time that that's going to be far too expensive for our purposes. So what we are doing here is we are using results from previous frames to smooth out the results from subsequent frames to keep the lighting sort of continuous over time. The reason that we do this is because if we have to compute sampled lighting every frame, the amount of noise that we're going to get there in our results is going to be very high, simply because we can't spend the amount of time we would need to take enough samples to get a really good, accurate result for every frame starting from scratch. So what we need to do is start from a previous result and refine that result with new information every frame and keep that continuity so that the user doesn't see like big flashes in the lighting. What this means is it creates a very difficult problem for us in terms of bookkeeping. It doesn't create a problem for us in terms of computation. The computation is getting easier when we do this, and that's why we're doing it. But it creates a problem in terms of bookkeeping, because in order to figure out what last frame was lighting-wise, we need some way of corresponding the solution that happened last frame to the solution that happened this frame. And that means that we need to store our lighting in some persistent storage. So what we were doing previously is we were caching it based on some IDs, and we never really had a scheme for how we were going to do those IDs. When I went to actually put that into practice, I realized, hey, wait a minute, I don't even really think I need to do an ID-based lighting scheme. Actually, what I could do is just have entities in the entity system store their last lighting information. Why not? And then they can always throw it away when they get far enough away from the viewer to know that we don't need to know what their lighting was last time because it's irrelevant now, right? So we actually made that change. It wasn't too hard of a change to make. So that structural modification has been made. And the way that it works is, if you remember, we sort of have a world that's chunked up into pieces, right? These are world chunks. And it's a three-dimensional grid, so actually, you know, it's something that's this sort of a thing, right? And if you take a look at like one of these chunks, inside it, we store all of our entity data, right? And right now, we haven't done anything to compress that entity data, but in the future, what we'll probably do is take the full notion of what an entity could be, which can have all sorts of huge stuff. And maybe it's like a 16K giant piece of information. And we'll just take the part of it that actually matters. So if it's something that doesn't, you know, it's not on fire, it won't store fire information. It doesn't have health, it won't store health information, right? So it'll just store the compact version of the entities. What I decided to do is say, oh, well, if we've already got this notion that we're going to compact entities and put them into storage, why don't we just also have the idea that when we compact entities into storage, we can also go ahead and put the lighting information into that storage as well. So that's all we decided to do, was put the lighting information into here. And so that's the entirety of the change. So it's actually pretty efficient, I think, and will be pretty good. The problem is nothing in particular with the scheme. It's just we've got a bug or bugs in our implementation of the scheme. So our job today is just to go through this system now that the change has been made, go through it with a fine-tooth comb, make sure it's working correctly, because it obviously isn't yet. And then when we're done with that, we can proceed to do more optimization on our lighting now that we know exactly how it will be stored and updated every frame. All right. So let's pop over to the entity and remember exactly how this is working. You can see we have lighting point state here. And what this is it just stores, like I said, we're not doing anything efficient right now. Entities are just these big old piggy structures that, in fact, I don't even know where the pig hat is. Do we still have the pig? Yeah, we've got the pig hat here. I'll put it on. So we are not trying in any way to do anything efficient here. We're just saying, okay, this is a problem for a later date when we're going to have this packing concept here. And when we have this packing concept, we will just pack in exactly the right number of these things, right? So however many it is that an entity has, if it's got, you know, 2 pieces and only 1 piece has lighting, then we would just store the 1 piece worth of lighting in a compressed sort of format. And then if an entity doesn't have any lighting at all, we wouldn't store it, etc. But for right now, we're doing the maximally piggy thing of just, hey, the whole big, gigantic entity, we're storing them all. Why? Because it's just not the problem we're focusing on, and introducing that extra complexity means it will create more work for us all the time because we have to be thinking about that. So again, that's a change we want to delay until a future time when it actually becomes relevant to us, rather than doing it now when it would just cost us development time through the entire development process. So it is important to make sure that optimizations like that happen at the appropriate time and not earlier. So in here we've got the lighting point states. These are the states of the points that are tracking the lighting information for this entity. And what you can see if we bop over to, I don't know why I'm saying bop all of a sudden today all the time. If we head over to the lighting code, you can see in here what the lighting point state actually stores. The emission, which is a color value, and the brightness thereof, and then a directional value, which says the average light direction for the light that's incoming. And this piece of information is the piece of information that we are tracking frame to frame because it needs to get like sort of average to smooth things out. Then we've got the lighting solution here, which is the thing we're actually working on. And what you can see is that just has a bunch of light boxes, and those light boxes themselves have the information that we're talking about here in terms of what goes with what. So the lighting boxes have all of the information about, an individual cube that's going to collect light or block light. And then it has the lighting storage and lighting indices, which are basically used in that computation to first refer to the previous frame. So this pointer here will refer to the entity storage there that we're talking about, that it will get that emission from. And then furthermore, we have, by the same token, indices into the main lighting array of where those will actually be stored when we're processing them, if that makes sense. So, and you can really think of these as just another pointer, effectively. It's just pointing into a known array, which is like these emission things here. So that's how this system is supposed to work, and we now have to just make sure that it does actually work, because it doesn't appear to be doing something correctly. That may be something small, maybe something big, but we need to go find out. So what you can see in here is when we do, excuse me, when we do push a cube on, what we do is we create the bounds for it, and we see whether or not it intersects the lighting. If it does intersect the lighting, then we figure out how many lights there are going to be in it. And we sort of do this in an ad hoc fashion at the moment. In the future, we've kind of tried to set up the system so that we can adjust the number of lighting points to suit our needs. And this may become important, right? When we're generating the world, we may decide that we need to have different ways of testing lighting across services, because some services want more light points, some want less, to keep things efficient. So right now, we do this in a very ad hoc fashion where we just kind of slam in some light points by default across the cube without really having any information from the user about whether or not it should be highly tessellated, low tessellated, whatever. But that's what's happening at the moment. So we just pre-compute a number of light points. That number of light points is going to be 4, right? 4 per surface, because there's 24 per chunk, and each chunk gets divided up across 6 faces of the cube. So the light points per chunk will end up being 4 in this case. We take the light index and we assign the light index to start with to be whatever the place is in the light index array that we've come up to at this point. And what you can see here is we then advance by that many, by the amount that's in the chunk, right? So this is basically our way of allocating 24 light points to every cube linearly as those cubes get pushed onto the renderer. So then inside here, we create a light box in the same fashion. We just push one on linearly as we get a cube. And then we fill out the light box. And the light box has light indices that correspond to every 4 light indices in that block of 24. And you can see that the last one here is actually assigned to the 25th light. And that's because this is a stopper. It basically says, here's where the lights stop. So this is face 0, 1, 2, 3, 4, and 5. Those are all the faces of the cube and where their light indices start inside the range. And then here's light index 6, which is not an actual light you use. It's just like an end cap. And again, that's a very standard way of doing arrays where you just have indices in them and you need to know their spans. You need to know where the last span stops. You just add one extra index so that you don't have to store a count for every single one, since the count's always implicit by just differencing with the next index in the array. We then push this on by taking the light index, which again has not moved from what it was, so it still records the last light index, and we just move it up, right? And the light count in this case will be 0 for anything that doesn't have lighting. So if it didn't intersect, then it will get assigned light indices, but it won't get assigned light counts. So I believe that will prevent it from participating in the lighting. Maybe I'm wrong about that. So we should double check that. But presumably, if you always push 0 onto the lighting, then the shader will notice that there are no lights that it needs to sum, and it just won't bother summing them. And again, where that happens, and I can double check this for my own purposes because I want to make sure. In the ZBias program, which is the thing that does the initial rendering and computes the lighting, you can see in this program here, that's the vertex shader, you can see in this program here, when it goes to sum the lighting, it's going to loop over the light count to do that, right? So if in the case where there are no lights, we would expect in here there to be early out. Let's take a look if there actually is. Where are we here? Where's our sunlight call? Sunlight, oops. Sunlight, not sunlight. So that's actually not right. This is wrong. Because it's the frag light count that will be equal to 0. So this is actually incorrect, I believe. I guess I say. So I guess, I mean, if we look at what's happening here, the result RGB is it's just going to come out as zeros here because you're going to hit this and the light count's going to be 0. And so I suspect this will make anything that doesn't have a light index just end up being black, is what it looks like would happen. The reason that I don't... Oh, we're fine. So actually this is fine because light count will still be 0. So this will be 0 the entire time too. So both of these will be 0. Never mind. So that's fine. So that's why I was going to like the trees should be black if that was the case. But yeah, it's fine because remember, light count only gets set in the case where we actually enter this. So this is actually fine. No need for worry. Anyway, that's how cubes get pushed down. And what you can see based on from how they're pushed down here, you can see here that the light point state is passed in, and this value here tells you what the storage address is for the individual light points that need to get written back. So we pass in a light storage pointer here, and that light storage pointer gets written back to the light box by saying, hey, when you go to keep the results of the lighting that you're about to compute on this frame, they go here. And by the way, you can also, if this looks valid to you, you can grab the lighting out of here to use in this computation. So that's what's going on there. Now, I want to make sure, and I guess we can do this in the debugger a little bit later, I want to make sure that this light storage actually round trips okay, because we have inside the sim region where these things get copied out, we need to make sure that they're actually copying out the light information, because I don't know if they are or aren't. I'm assuming the whole structure gets copied at this point. It's been a long time since we've done anything with this, and so I don't know if there's any intervening factors in here that cause that to not be the case. So I believe it would be in begin sim or begin world change, I guess. So inside begin world change, you can see here is we have this sort of entity struct here that gets pulled out, and I believe we always just kind of write the source to the dest. Yeah, so you can see right here where we've got decompression step, the source just gets moved into the dest like so. So since the source gets moved into the dest like that, that should mean that all of the lighting gets copied in. And then the question is, in end world change, does it get copied back out? And here you can see it should be getting copied back out as well. So these are the two steps, the compression, decompression steps that are happening that really don't do anything yet, but will eventually. They appear to be copying the light, so we would expect it to be persisted properly across frames. Inside the lighting, we now have to go take a look and see whether we're actually obeying any of this stuff properly in the first place. Inside the lighting routines, because they've been modified a bunch of times now as we've been playing with stuff, it's possible that we just messed them up. So when we come into lighting test here, what you can see is we first remember how many boxes we started with, because remember, we're going to do a spatial hierarchy. We create new boxes that basically encapsulate different sections of the world so that we can cut down on the number of things we raycast against when we raycast. So if we take a look at what's going on in here, when we do our lighting test, when we excuse me, when we go ahead and process this information, we go through each of the original boxes that was pushed on there, and we are sort of doing our copy out right here. So this is the part we have to look for to see whether or not we're picking up the previous frame's lighting correctly. So we go through each of the boxes, we look at what the first light index is for that box. We go over each surface, right? So we go for a particular lighting box, we go from 0 to 5 each of the faces. We get out what surface that is by using the radius and point position of that light box. We then take and subdivide each face, and we put points in for that face. So we start out at that initial light index. We go through by adding the base point array. We look at each point as we go. We record the surface normal and the actual location of the point by displacing it. This is basically creating a location for this point that's on the box, right? Again, nothing particularly weird here, kind of straightforward. And the surface, all the surface information is the same as we were using before. We just use this routine to create information about the surface. We create the reflected color by pulling that out of the box. That was stored when we actually made the box in the first place. And then when we do our emission, we take whatever the emission value is passed down, we multiply it by the max light emission, and we track that value through the pipeline, right? You can see in here by taking whatever the emission value is that's passed down, and we blow it out to white, and then so because you know it doesn't right now we don't pass down RGB emissions. We could, we probably should. So anyway, we store that for whatever light index this is. We store that in the emission array, and again, that's the absolute light index that we got. We then increment the light index. At the end of this, we would expect the light index, and in fact, I should just go ahead and assert that here, that after this is all said and done, the box light index 6 should be what we ended up with. Oops. And in fact, I could just make that happen here to say that whatever the surface index plus 1 is, right, that's what we should have ended up with at the end of every loop, right? Because for each surface, we should output exactly 4 of these, and they should line up with what we think they are in the box. So that looks roughly correct here. What I would say is just, you know, this doesn't copy out any information about the light yet. The reason it doesn't is because right now in fact, this is the to-do for it right here. Right now we don't reload the emission, we just blend with it after. That's probably not the best we can do, but it's what we were doing before. So I want to keep it with what we're doing before. I don't want to add any new stuff in here while we're just debugging. So we're going to leave it that way for now. We then come through here, we do our light propagation computation. I don't know whether we're supposed to 0 emit C. I don't think we are, because the emit C just... Let's think about this. The dest emit C should always be cleared by the previous loop. And it should start at 0. So we shouldn't have to clear that. And we could assert on that, right? We could come in here and go, all right, if handmade slow for point x equals 0, point index is less than point count. So right here where we're about to go into this stage of the game, what I could do is say, all right, my lighting point I want to make sure, actually that's wrong. It's just the emit C. So it's just this stuff here. So what I want to do is say, all right, my emit C1 equals, I guess I'll just get the actual one out, equals whichever one we're on right now. And I want to assert that this is set to 0. So that's just a check to make sure that that always is starting off cleared, because again, we expect it to always to start clear and always be cleared by the previous frame. But who knows? Maybe we've got a bug in there. So I feel like we want to make sure that that's true. And so I'm just going to go ahead and say, you know, make sure that's true. When we do compute light propagation, we're going to have to go check that routine in a second. But right now, let's just go ahead and focus on the final stages here. So if we assume that the light got propagated properly, because we never really touched that routine, so hopefully it's still fine. We then got to loop over all of the boxes that we have, again, doing the exact same procedure that we did here. And for each box now, we have to copy out the light state, blend, and store, right? So we grab out the box, we grab out where we're storing it, and then we want to look to see whether or not this was valid. The way we're doing that is we're looking at whatever the stored direction was, and we want to make sure that the stored direction is actually not all zeros, because the direction cannot be all zeros. A direction always has to point somewhere, right? So the only times we could ever have a direction of 0 is if we are starting afresh, so it's just a cleared array, so it's the first lighting solution, in which case we have nothing to blend with anyway. Or we didn't collect any light for this point. We just never saw anything, in which case, again, we can't blend with it because it's not a valid, so there's been no light there, right? So we wouldn't have any information. There should always be light coming in pretty much everywhere, most of the time, I would think, unless we created an area of the world that was literally pitch black. At that point, we may have to rethink this and maybe have an actual flag that says whether the lighting was valid or not. At the moment, though, we're just going to assume that it's fine to use this. Now, we wouldn't actually need a flag. We could just set one of these to be some bogus value. In fact, you could imagine setting one of these values to like 1,000. We know the direction has to be normalized. So we could just set the value to 1,000, and you know that can't ever be true. So if you see direction x equal 1,000, you know this is an invalid point. If you see anything else, you know it's a valid point, right? All right. So I can actually put that in here to do. Casey, maybe we should init directions to have an x of 1,000 or something, so that we can handle points that get no lighting. So we go through here and we say, if this was a valid point, then we're going to have to do a loop that actually blends. And if it's not, then we don't have to worry about that. So let's start with the blended one, because this is the one that happens on most frames, since on most frames, most points will have had lighting the previous frame. We go through and we loop through the local index. The way we loop through the local index is we take the total count for how many there's going to be. Let me go ahead and pull that out. Because that way in the debugger it'll be easier for us to inspect. So here we're going to take the last light index for this box and the first, and we're going to subtract 2 so we know how many to loop over. We're going to loop over that many, and the global point index is going to be equal to whatever that local index is plus the base index, which is the one we're sort of working off of, first one for the box. We're then going to say, all right, into the box itself, store back the emission. Also store that into our light array, because we're going to use that later to output the points. We could probably do that right in here. So output lighting points actually could be welded directly into here, probably. To be honest with you, that's probably what we should do, but you know, I'll go ahead and say that that's something we want to do. Anyway, we store it back to the 2 places, like so, and then we perform the actual lerp to get it. And the lerp is between the box storage local index emission, which is the one from the previous frame, and the new one that we've computed, right? So we're just doing that blend and storing it back. And the t value is how far we're going, right? Which at this point is just a fixed value of 0.1, right? And right now we just know that, you know, we just blend towards the new lighting solution, and we don't really have any rhyme or reason for how we're doing that. We just know we add a little bit every time. So this probably will get better as we start to think about how the lighting is sampled and make more intelligent decisions here. We then do the same thing with the lighting direction. So to do the lighting direction, what we do is we store back into the box and into the average direction to light array the normalized version of the lerp between the average direction to the light from this frame and the one that we stored on the previous frame. Now you'll notice we also normalize the one that we computed this frame. The reason is because we don't want to lerp between one thing that's been normalized and one thing that hasn't, because the thing that hasn't been normalized will dominate because it will have been, it's too long because it's a sum, right? So it needs to get normalized down first. So that's how that works. So if we come through here, we can see that the other version, which assumes that the points were not, the previous state was not valid, right? For the previous boxes, we're doing this per box. The particular box in question was not valid. Then we're going to do the same loop over the same indices. In fact, we can pull this out. Like so. And what you can see is if I loop over these, we're doing exactly the same thing we did here, but the difference is now we don't blend. So we just store back the exact results we got this time, and that's all we're doing. So yeah, we still have to do the normalization, but other than that, that's all that happens here. So that looks pretty sane. I don't see a lot of weirdness happening, honestly, there. Oh, sorry, output lighting textures is what I meant. So if we take a look at output lighting textures here, output lighting textures goes through all the points and does some, let's see, what is this doing here? So really all we do here is we just store the location and the color, and we store the direction, we pack that into the W coordinate, and it looks like because we have to be able to reconstruct the Z, I don't know why we negate DZ here because we're never going to use it. So that's really just superfluous, right? The DZ never gets used. But what we do is we negate the red channel. I should put a note in here. So we need to basically record what that sign of that DZ was because we don't know which it is. It could have been either because the only constraint on the direction is that it be normalized. It doesn't have any implications for which direction it has to be normalized in. So for example, take the easy case where you've got a normal that's 0, 0, 1. Well, all you're going to get is 0, 0. And you'll have no idea whether it was 0, 0, 1 or 0, 0, negative 1. So you need one more bit of information to determine which of the two square roots, right? There's a plus or minus in the square root. Which of the two you're going to pick. That's all we're doing here. So that's really it. And like I said, this output lighting textures is really something that can be done directly in line with the copy out here. So we could just be doing that, and then we wouldn't have to copy the emit 0, like emit C0 and average direction to light don't actually need to be written back to themselves in that way. We could just write directly to the textures at that point, which is what we would probably want to do. All right, so that's the complete round trip. Build spatial partition for lighting is presumably not implicated here because it doesn't do anything differently this time. So the only thing that we're really talking about here is compute light propagation. Compute light propagation hopefully is working correctly. Let's double check it. And then we just get down to debugging, stepping through in the debugger, because I don't see anything semantically wrong. So far, everything seems to be doing what I would expect it to be doing. So inside compute light propagation, we start with emit C0 and emit C1, as we would expect. We go through the number of iterations that we want to go through, and we assume that the light power distributed every time is going to be the total number of rays the light retention per iteration is going to take away from the lighting. So however we would distribute a full amount of the light power each time minus however much we want to retain each time, and then we divide by the total ray count to figure out what's going on, right? And again, this is going to get tuned quite a bit more in the future. We loop through all of the emitters, and for each emitter, we go ahead and, also, just curious here. So in here, light point index should start out at 1, right? And presumably right now it's not. I actually want to catch this bug because I think like this is a little subtle bug here. So in here where we do light index and we assign the light index, I want to assert that the light index is not equal to 0. And I think we're not handling that case at the moment, so I feel like this should assert on that assertion. How is it not? Are we actually setting light point index here? Oops. So we are actually setting light point index here in the render commands. I feel like I want to take a quick look at that. I guess that is the right place for it. All right. Well, all good. So when we're running this here, we also are doing the debug check now too to make sure that those emit C1s are valid, which they apparently are. So that's also good. All right. So let's go ahead and keep going here. Inside our compute light propagation, we're going to loop through each of the points that we have sort of packed into the light array here. We go through each of these and we say, okay, let's go ahead and check to see whether there's any emission coming from this particular light point. Assuming that there is, we're going to go ahead and cast some rays from it. We will sample the hemisphere to figure out what direction we're going to send the rays, and we'll do the ray cast as a result. Inside our test here, if we hit something, we see which light index we hit. We grab that out this way. We also get the number by looking at the next one and subtracting it. So this is how many of them there are in question. We then go through each of those and we say, okay, for each of those light points, we're going to go ahead and take whatever the surface point index offset is here. We're going to offset it from that base index. We're going to look to see for that particular point, how far away are we from it? If that's the closest one, we'll keep it. We then go ahead and do our all of our work on that particular point, and off we go, right? So again, it looks all pretty straightforward here. I don't see anything particularly weird or interesting, actually. We just have a basic copy back that happens. afterward here. So that's all pretty straightforward. Yeah, that seems fine. So yeah, I don't know what's wrong at the moment, so we're gonna have to dive in a little more detail. I also feel like at this point we should, because we're debugging, we should get our F1 working again. F1 was supposed to draw the lighting points. You can see it's not drawing any lighting points. So let's go ahead and get that routine working as well, because we're gonna need that for debugging. It's a basic visualization that we need here. So inside output lighting points, I believe that's what happens when you hit F1, right? So what we need to do here is we need to figure out how to make this thing work correctly. So we do a get current quads with the point count. That's not correct. Actually, what we're going over boxes here, and plus point count, it's going to be 4 times the point count. No, I guess that's right, because there's 1 for every point. So that seems fine. So anyway, we come through here. We're going to do get current quads for the point count. Yeah, we loop over each of our boxes. For each box, we go through each surface. We get the surface for each of those. We take a look and we go through the point indices for that particular surface. We grab out that point. We take the p-value of the point, and we take the emission color. We then go ahead and do the clamping here. I feel like this needs to get adjusted because the emission values here are going to be wrong. That's all right. We'll deal with that later. So yeah, so then we clamp the emissions, we draw the points. That all looks pretty sane, right? So I think we're getting some problems where our light points are not getting initialized properly, is what it looks like is happening, actually. So it looks like something bad is happening in here, that we're like writing to the wrong thing, or something weird is happening, but I'm not exactly sure what. So let's take a look in that routine, actually, assuming I still got that breakpoint set. Yeah. So when we come through here, like, what are our p-values, for example? Are they, what just happened? Are we just not setting the point count? So we're setting the point count to the command's light point index. We're setting the box count here. What's going on? So my light box count is 0. I guess that's because in this case, when we do output lighting points, we have not actually called the lighting routine yet. So when we do update lighting here, and we're probably going to have to move this down so that we actually just do the if around the lighting textures, and we output the lights, which we can do now that the lighting runs more in real time. Before we couldn't do that. So that's fine. I don't mind making that change because, like I said, the lighting is supposed to run in real time now, unlike before when it was running in non-real time. So I'm okay with that. So if we want recompute lighting, yeah, so all this stuff is really, we can clean this up quite a bit now. Yeah, there's just a lot of garbage in here. We can clean this up and make this a lot simpler now that we always run in real time. So what we can do here is just have the show lighting information just be a visualization that happens here. So really what we can do is just say, all right, in here, we know we've got this sort of show lighting debug thingy that we're doing here. So I can just go ahead and grab that. and say if we're doing show lighting, then we're going to do that. Otherwise, we're going to do this, right? And the crucial thing here, I guess, is that after we've done all of this and passed all of this information down, we actually need to we need to take all of that stuff that we would have drawn, and we need to not draw it, right? Because this will output the lighting points like on top of what we were doing before, and we don't actually want that to happen. So what we need to do is, after we do the lighting test and we were going to do output lighting points, we need to do a we don't really want to call it a clear because that's just clearing the screen. Discard all render commands. We need to discard all previous render commands, kind of a thing. So, you know, we did a bunch of rendering. We don't want to do it anymore because we were doing it just for the sake of computing some lighting, and we're gonna do like a test render here. So just don't do that. So we needed something that discards all of that, and then we can go ahead and do output lighting points on that frame. And that's all we really need to do. Now, updating lighting is something that we still probably want. Updating lighting. That is something that probably also wants to get done. So in here we would have this like so. So when we go through to do that lighting test, yeah, we would need to call that function so that the lighting information is valid at the time. How we would get it... Why was the box count getting cleared to 0? I don't know. So that's a little bit confusing, actually. Because the test lighting should not have been... We'll take a look at that in a second, too. So that kind of needs to get... addressed as well. All right. So we can get rid of those. So in here, I think all we really need to do is say, well, no matter what happens, I guess we can just leave lighting enabled. I don't think we ever need to disable it. If we do, we could just disable just that one part. So I think this becomes a little bit more straightforward now. So we really just need these two things, F1 and F4, and then the iteration counts we can adjust as well. Obviously, we can leave that happening. But I think all that is really the only part we need. And then if we take a look in here, we've got the updating lighting and the show lighting. I think that's all we really care about. So I think that's all relatively straightforward so far. And so all we really need now is we need a way to actually do that render group discard. So in here, what I'm going to do is I'm going to define this thing. And all this is going to do is when we go, you know, look at what's in these render commands, you can see that we've got sort of this, this set of things we're streaming out here. All we really have to do is just reset those, right? So we just have to take that command structure. Oops. And clear it out. So we basically reset the push buffer data at you know what though? We don't really want to render the quads, but we probably want to leave everything else intact. In other words, we probably just want to change the vertex array back. So honestly, the only thing we probably want to do here is just say vertex count equals 0. I think. Yeah, it's not that simple though, because we have the records of the push buffer on there. You know what? Since this is debug, why don't we just let it render and then clear? Actually. That actually seems like a better idea. That way we don't have to worry about any of that stuff. There. Now we can actually output these and hopefully see something. That does not look like it cleared. I think that's because it's inside a depth peel, unfortunately. So I think we would probably have to do the end depth peel first. Now, to be honest with you, I don't know why end depth peel couldn't happen before end sim, because end sim is not rendering. So what we could do is just do it here. And I would have thought that clear would work. So it doesn't seem to, though. So we should go check why our clear doesn't work, because I think it looks like everything else is working. But I would like to be able to clear the screen there, because I don't want to show anything else. So inside the OpenGL layer, where I look at the clear, is this just because we actually don't process clear commands? Yeah, I think the reason for this is it looks like we just don't actually process clear commands as actual commands. You can kind of see right here what we do is we just take and we clear at the beginning, but we don't actually do a clear command. So we should probably put the clear command in there. I'm not sure why we don't. It might have been historical, because it seems like it should be fine to put the clear command in here. Like, I don't see any reason why we couldn't do that. Let's try it. So we'll call this a full clear, because it just wipes out everything. Oops. And then inside the render group, we'll make a full clear to go with our depth clear. The depth clear looks like it doesn't have a struct associated with it. Do any of these? They don't. So it looks like only textured quads actually has any data, which is fine. So let's take a look. So that clear color that's in the render commands, I'm going to get rid of it, and I'm going to put it over here. And I'm going to leave that comment there because it's the same thing, right? We're going to use the same value there. And we're going to go from here. So when we get a clear now, this is going to actually change the information. I don't know. I don't know that we'll have to change the fog part. The fog part, I think, should be fine. Yeah, and all this should be fine as well. So in here where we get the header out, when we actually need to get the value from this, it should just be this right here, the same code that we were using before, where we get that full clear. And then in here we can say, okay, for each of the things we're going to do now, instead of getting the clear color out of the render commands, we're just going to get it exactly as we would have before. And off we go. I am not sure what this wants us to do. So this is basically saying like whatever the clear color, whatever the last clear color was, we're going to use it. I don't know that I care about that just yet. So instead I'm just going to say like, okay, just clear it to black for now. So now we can do an actual push here that pushes actual information onto the render stack. And yeah, that should just look like this. So now in here, when we go to do a push render element, we're going to push on a render entry full clear, like so. And so now the clear color gets stored directly in the entry. I think that will work. But I don't know, so we'll find out. So when I say I think that will work, is what I mean is it won't work at all. So it looks like inside of the OpenGL layer here, when this clear happens a couple times. Let's see. It's basically right here. And in the cutscene code. So this has to happen actually, I guess, outside the depth peels as well, I think. because the depth peels are a special block, so the clear can't happen inside there. Yeah, okay, so that's all it was. So now, in theory, we should be able to figure out a way to make sure that this actually works. We needed to clear everything, which I thought it was going to do. I thought it was supposed to clear all of our surfaces. Because we go through every depth peel and we clear it. So I'm not sure why that shouldn't reset our state correctly, but it definitely doesn't. So insofar as we do all of our peels here, I had to think about how this actually gets composited on the back end. So, you know, the composite on the back end, it does the lighting peel composite. That's what this does right here. So when we do the lighting peel composite, my thinking here was that, well, we can just throw in a clear, an additional clear, and it should work because it'll just clear out the depth peels. So when they get composited, they'll only get the stuff that comes after. That was my thinking anyway. Because we know we can render stuff afterwards because we have, like, the debug system is rendering stuff that just gets rendered directly to the top depth peel. Right? I mean, that's supposed to work. So I'm not sure why we would have... I'm gonna... Right here, we clear out the depth layer for the peel that we're on, and we don't do a begin end peel here, right? There's no depth peeling, I don't think. Because the only place that does that is in here. So I would have thought that a clear plus the depth peel begin, we would go through and we'd do depth peel end, so this stuff gets rendered multiple times to each depth peel. If we then came through and did the clear and then did the output lighting points after that, I would have thought that would have been fine. But evidently clearing after the depth peels doesn't actually work. Apparently. Unbeknownst to me, or rather, contrary to what I would have logically thought, clearing in here does not seem to actually work. Now, the depth peel count is constant, right? And all of those depth peels are getting cleared. So the resolve multi-sample has already happened. All of these are getting cleared. I guess the main frame buffer... I guess the only thing is the main frame buffer isn't getting cleared, is it? So we've already done a resolve multi. This is only the depth peel buffers. So I don't actually know if we do want to clear those. That's a good question, but assuming we do, I'm going to say let's clear that main buffer as well. Yeah, that's just pure bizarre to me. I have no idea what's going on here, I'll be honest with you. This is the way of graphics programming since you can't step into it. I would feel like, so that what happens when I do an F1 is the inverse of what I would think. What actually happens is it clears everything that comes after, right? So everything that comes after the clear that gets inserted is what ends up being cleared, and the stuff that came before remains. Now what I would have thought would have happened is when this resolves, oh, that's not the main frame buffer. So here's the render entry end peels. This is still binding the last depth peel buffer, which is not actually what I wanted, right? What I actually wanted is for the end peels, what I actually want here is whatever buffer you were targeting to be cleared, right? I want whatever you were going to render to be cleared, and we need to rebind that buffer. So yeah, I'm not sure if I really want to do it this way. Maybe I just want to do this. It's hard to say, right? It depends what we want that clear to actually mean. So I guess what we want to do is when we do the clear here, we want to say like, okay, whatever the render entry end peels would have targeted if, you know, if you come through here and you're on the last one, we bind this frame buffer that's the one we're actually using. And that's what we would have to bind if we were currently on that one. So we almost need to like save and restore it here, which is kind of nasty. So like, I mean, you can see what I'm saying here, right? This is really what needs to happen, and it's just kind of ugly. It's very special case-like. But I feel like basically that still didn't even work, which is weird. But basically what happens is when we come in through here, we rely on the fact that we're targeting this frame buffer when we start, the first depth peel buffer. And then after we're done with the depth peels, we end up targeting this other frame buffer, right? This one here. So I guess actually technically it's this. And peeling, I don't really know, because peeling will start off as false. So the first clear actually doesn't even want to do that, which is even weirder. So who sets peeling to true? So the first time through, peeling is set to false, because there's nothing to check against, right? And then on peel index gets set back to 0 when you're done. So there's really no way to know whether you're in one of these or not. I mean, I guess one way to do it would be to do it this way. We would effectively have to track, you know, which one of these we were on. Since this is messy enough, I'm going to say let's go ahead and do it. Let's go ahead and actually try to clean this up a little bit, because it's just kind of bad. So what we could do here is say, well, all right, when you do begin render entry peels, maybe that's when we target a buffer, you know, because you look at these, we're going to jump back. So, you know, you're going to come through, you're going to begin the peels. You could just do this. I mean, I feel like you could do this anyway. Where you say, all right, when we begin peels, we target whatever the peel buffer is that we're on. And then at the end, you know, we increment the on peel index. And we jump back. And similarly, you know, whether we're peeling or not is in here, which is different from whether we're on a peel or not. Assuming that we don't do that, we're going to fall out of the loop. Then we bind the other frame buffer, and we know that peeling is false, and on peel index also has to equal 0 because of what we're going to do inside the peel thing. So that's at least a little bit cleaner there, right? So that when we go to like start a peel, we know what's going on there. The thing I suppose we could do is clear at that point. So when you do a begin peel, you would clear the peel. But I don't know if we want to do that differently where we allow multiple peel sets. That doesn't really work. So I almost say this clear should really be here technically, meaning when you bind the peel buffer, then that is actually where you would do this. And so this entry would be a real entry, right? The render entry begin peels would actually be a thing that said what the color was. And in that entry, you would store what the color is that you expected to be cleared to for your peel resolve, right? You know, whatever you wanted that to be. Then when you were done with the peels, then it would resolve the multi-sample buffer, resolve it to the main buffer, and off you would go. And then you're going to be targeting the peel buffer directly from then on, right? The main buffer. I don't know, whatever you want to call that. And that seems fine. So then when you do a render entry full clear, you don't do this target index thing anymore. You just clear whatever buffer you're targeting, and that's it. I think. So I think that's right. So we'll see. So if that's the case, then what you end up with is inside render group here where we've got clear. I'm going to call that something else. Where did that go? So in here, I'm going to call this push full clear. So we're super obvious on what it's supposed to be. Full clear. Depth peel is going to get its own one of these entries now, which also has the clear color in it. That seems about right to me. So the end depth peel doesn't have any information in it, but the begin depth peel does. And that's, I think, a better way of looking at that. Then we would go up into here and say that this is a real citizen now. So in here, we don't actually need to do a clear anymore, I don't think. I think we just do that. And then the clear functions that we actually have, this is a push full clear. That's going to do the real clear. I don't know that this actually needs a full clear. To be honest, I don't think this one uses depth peeling either, but we'll have to look to see what's happening there. Exactly. So we'll just leave those as full clears for now. So when we begin our depth peels, we need to know which target it is. We need to know which one we're doing, and we want to know if it equals, if it's the last one, right? So the first time through, it's at 0, and when it gets to maximum, it's going to stop. So I think all we need to do here is just say, all right, look, whichever one we're on, that's going to tell us whether we want to clear it to nothing because it's a depth peel, or whether we want to clear it to the background color. So it's the last one we're going to do. We'll fill in the background color there, right? So I think that's roughly what we want to do. But it looks like we're not quite there yet. We're close. So I think that's a little bit cleaner with what's going on, but still, yeah, okay, not quite there yet. So let's go ahead and finish this off. So when we come through with the peels, I guess the only question I have here is exactly how these are getting bound. So if we're peeling, we use the previous depth buffer. And that seems fine. And that would have been cleared because it would have gotten bound. And when you enter into the peel, it will clear that peel, both the depth and the color, right? You can see those two there. So my only question is this guy doesn't seem to be actually happening. Meaning this clear color bit here assuming we're tracking it right, that should be gray there and is not at the moment coming through. So this right here is perhaps not setting on peel index correctly. So on peel index will start out at 0. The first time through it will clear it to all nothings and go. It'll increment when it gets here. Whatever max render target index is, shouldn't it be depth peel count? I'm not sure why we have two specifications for that. Yeah, because it's just the depth peel count. -1 here, which doesn't seem logical. I mean, basically, what we're saying is that this is the max render target index. So we're saying if the on peel index is less than the max render target index, then we restore it and jump. But if it's not, then we bind it. So what's interesting about that is for some reason we didn't use it here, but this is really all we're saying. We're just saying if it's on the maximum, then we should clear to the clear color because it's the last one we can draw. I don't know why. We must just not have, like when we were originally doing it, we must just not have replaced it, you know? So that seems fine. So the other thing I would say is I don't know if we really want this other global here. I don't like that. That seems busted. So we're going to go ahead and get rid of it, I think. And say, look, on peel index is just going to have to tell you the information that you need. You know what I'm saying? So basically, you only get one piece of information, and that's on peel index. And on peel index has to give you the information that you're looking for. If you can't get it from that, you don't get it. All right. So resolve multi-sample presumably reads from all the peel buffers and puts the results so we're going to take the frame buffer we're writing to and we're going to put the result in there by reading from all of the color buffers. You know what I'm saying to you? So if we look at where resolve multi-sample is going to, when we do end peels, we resolve the multi-sample to the depth peel resolve buffer for that peel, and we do the resolve multi-sample there. And that gives us the final result that we're going to composite later, right? So it looks like that kind of educates me as to what our problem was. So because we leave the depth peel buffer sitting around, then it really does mean that the clear would have to clear all of them, right? It can't only just clear the one of them. Since the clear depth is always the same, I'm going to leave that outside so that when this gets cleared, it will get cleared to the right values. I'll leave this expanded there. And so that means that the full clear would actually have to discard the data that's in all the peeling buffers, unfortunately. So when you do see the full clear, yeah, it's going to have to... It's going to have to do that targeting. But I still think that should be okay. So, all right, let's keep going here. So again, we're getting a little closer as we clean this up. You can see now I can actually see my lighting. Points. I'm getting some weird like blitz stalls, so you can tell we're just a little bit wonky at this point. And you can also see that the lighting is actually, for the lighting points, it actually looks about right. Which is bizarre. So it seems as though our main problem with the lighting is actually in the correspondence of lights to polygons at the moment, because you can see that it's not all flickery here, but if we switch back to actually drawing, the sampling is completely wrong. So that's interesting. And that gives us some more data to work with as well. All right, so moving on here, when we take a look at what's happening with our depth peels. So this is close to right now, but I still think it's subtly wrong. Well, no, you know what? I think this might be fine now. We're clearing the whole thing, so when the composite happens, we actually should be okay, because the depth buffer and the color, since it's clearing the color to a 1.0, that should not allow anything below it to show through. So I think this is actually right now. I mean, right in big old quotes there, but I'm not sure. Oops, I'm not sure what's going on with our frame rate stutter though. Something weird has happened that I'm going to have to track down. It might just be, it looks like when I run it in release mode, we're getting full frame rate here for the most part. So yeah, it might just be the debug situation being ugly, but it might be something to look at in a second. So what this tells me is we're getting some kind of an anomaly, because if I switch to this mode, the lighting does not appear to be as messed up, which is a little bit weird. Now, I do still see a lot of flickering out in these regions, so I'm not sure what to make of that. But you can see the lighting is very smooth in here, and when I flip back, it's all crazy. So it feels like we first have a correspondence bug, actually, where we're not corresponding the samples for the quads with the lights, or we're not downloading them, right? So when we do like output lighting, for example, In here, maybe this output lighting textures is busted, was one possibility. Another possibility is the things we're writing into the actual push quad are broken. So if we looked at where the things were lining up, they wouldn't line up properly. So I'm not sure which of those is happening, and we're going to have to figure it out, right? If we take a look at what happens here, we're just sending down the full size of it every frame. And we send down the light data in the light data 0 and 1 arrays. So there's not a lot of weirdness going on there. It's push lighting is literally just doing these two copies, right? So, you know, this is the routine where we get the information from. We get it by sampling these point indices, the point indices for the whole set of points, and we're just grabbing it out of the solutions that we had. There's nothing else happening in there. Excuse me. So it's very straightforward, and it seems like it corresponds with this routine pretty directly. This is just taking the point P and the emit C and drawing them. But you know what? You know what we're not doing here? So we aren't properly handling the max emission range. Where is that Z-bias program? So in the Z-bias program, when we do our summation for the lighting, we should be blowing it out based on how much light is available. But we're not doing that at all. So we definitely have some issues here. In terms of clamping. But we do clamp it here. So we're just passing down points with the emission baked in to full emission. So I guess there isn't a problem because the light data gets sent down as floats and processed as floats. So the light data is stored as actual float values at the moment. We don't actually pack it down, so I guess that's fine. So the fact that it's an emission, the emission value gets blown out by the max emission value is actually totally fine. I was a little bit nervous about that, but looks like that's actually not a problem, at least not that I can think of at the moment. I just want to take a look at this push cube function just real quick. So when we take our light index here, I want to make sure that these are getting corresponded properly. So we have a count. The count would be 4. The light index would be strided here. Yeah. Don't see anything peculiar going on there. So I'm not sure. I don't know what we're getting in terms of... Let me go double check push quad. I don't know what's going on there. It's light count light index, and that gets set on here exactly as we would expect. And in here, I mean, that looks fine to me. So I don't see what the problem is and why those wouldn't be corresponding properly, but we definitely know there's something up. Because we can see when we actually output them the other way that we don't have that problem. I'm going to take a look at output lighting textures to see what's going on in there. So if I take a quick peek in here, I just want to see some things like, oops. What does the solution say for how many points there are? That's the value we would expect. What kind of position does it think it has? What kind of color? What kind of direction? So we definitely have some points that don't have very much light. In fact, everyone has very, very low light. Which I'm not sure exactly why that would be, because again, we're looking at them in the other... Let me let this run a little bit. It's just really tiny light values for the colors in emit C0. And I'm wondering, so if I were to switch to this one, would I suddenly see something different? So what do those same values look like if I look at them here? So they definitely don't look all that unusual. I want to try one more thing, because they don't look that different between the two, and yet one visualization looks okay and the other one looks wonky. I want to try forcing valid to false. So forcing valid to false will make it so that I always see exactly what this frame computed, and I never average with the previous frame, right? That is just so weird. I have no idea what's going on here. Like, the lighting samples for the quads are totally disaggregated. So this has nothing to do with storage. So storage is now out of the question. So the part that we changed is in theory not actually happening anymore, right? We're never looking at what the old values were. We're never taking this branch. We're only ever using the one where we just directly set the values. So, you know, whatever emit C0 was and whatever the direction was, that's what we send out. the pipe. It feels like we must not be going over all of the actual values somehow. But I'm not sure how. Let me look. So if I come in here to this function, I want to see which point indexes we actually do. So, you know, I mean, that sure does look correct, right? So those are the emission values. Let's take a look at the average direction to light. So these should all be like, you know, normal values, which they look to be. You know, either we didn't get any light, in which case we're 0, or we did get light, in which case we should be a normal. You know, and that looks reasonable. So I'm going to take one more look at this, and then I think the next tack I'm going to take is to construct a very simple test case that I can walk all the way through, because I really don't, I just can't guess what the value is. I don't have, I don't have a guess. I also don't know why is this gray. Like, why is that gray? It's happening. Is there a reason why it's grayed out? Is that just like a bug in Visual Studio? It's very strange. don't have a good idea here. You can see this is clearing the emission array. There's our lights. You know what I should probably do, actually? Let me go ahead and cut this down to the smallest possible, so I just have less things to look at. Because this would just be easier too. It actually also increases the frame rate, which is nice, so we can see. So again, that looks pretty correct to me. Yeah, all right. So if I go into the lighting here and I re-enable you know, that lighting looks pretty reasonable. I mean, it could still be buggy, but it's pretty reasonable. So then to go from that to this, when you're actually drawing the quads, I'm completely at a loss to explain why that's happening, because I can't figure out any reason why it would have that kind of a change. So I think the fact that it's emit C0, it must be the normals. Let's find out by just stuffing the normals with valid data. That's my only thinking here. So let's suppose we set all the normals to just be like, oops. So assuming we stuffed these values so that the D values are all bogus, right? Then what do we see? Yeah, it's still garbage. All right, let's stuff the color values. You know what I just thought of as well? No, okay, never mind. So I'm just going to stuff the color values as well. So the RG and B values are now all supposed to be the same. Lovely. So if that's the case, I'm going to now let the D values, let the normals be whatever the normals want to be. So I just want to see if there's noise there. So there's a tremendous amount of noise in the normals, right? that's just garbage. So even if you assume that the color values are the same, every frame, the normals are varying that much, which is ridiculous, right? I mean, that's just absolutely crazy. I mean, there's just no chance this is even remotely correct. And I just have no idea where that complete garbage is coming from. Because it feels like we're looping over the same information that appears stable when you loop over it per box here. You end up getting the exact same stuff we were getting before. But if you actually go through and output it per point, not so. And I have no explanation for that at all. I have no idea what's going on there. That's pure mystery to me. So I guess the next thing to do is I'm going to take a look and see if I have the color values and the direction values set here. I want to go ahead and set them somewhere else. So if instead of setting them here, let's suppose I set them, so this is actually outputting what it's supposed to output now, right? It's just doing the same output routine that it used to do. And instead, when I go up here, when I actually go to ratify these points, I'm going to actually set them to, I'm going to cold set them here. So I'm going to set valid to false, which forces me always into this loop. And inside this loop, I'm going to set the values so that they have to be specific things. So here are those two values that will be coming out as C and D respectively. And so I'm going to set them to exactly the same things I set them to before. And now run it. So I'm basically just isolating parts of the pipeline here. So what we write here does actually come out. If I was to flip this around now, I should see it shift over to blue. Lighting, and it does, right? So that seems totally fair. So the noise is definitely coming upstream somehow, meaning that the actual information we're getting out here somehow, and this doesn't make any sense because output lighting points is reading from the same information. So I have no idea how it's possible. I mean, I guess the thing is, am I like not rendering some of the points? Am I only rendering like a subset of the points? I don't think so. I'm thinking I'm rendering all of them. I should be able to see the noise in here. We're not drawing D, so D does not get drawn when we push this quad on. But, D is not the only thing that was problematic. So if I don't stuff the colors, let's see if it is only D. If I let the colors come through however they want, yeah, it's still complete garbage. So how is it possible that switching to here yeah, I just don't understand. Those two things should coincide, and they do not coincide at all. Right? They are completely fictitious. And furthermore, if we cranked up the smoothing on that particular Like, so let's say I blur it instead of over 10 frames, I blur it over 100 frames. So it's very blurry, right? This changes not at all. So it appears to just, again, be just random values that it's getting. This one should be much smoother. Well, you know, it's not. Oh, wait, no. That's because I'm not actually doing the smoothing. This one is now a valid test. So I guess what I would say here is that still seems wrong. So there is more to it than I'm making it appear, because if it was really smoothing over 100 frames here, we would have a pretty significant difference there. I guess the possible explanation is that because of the directionality thing, I mean, one way I could do it is say, let's suppose direction is always set to true. I'm sorry, val is always set to true, so it forces the blend case. Does that remove the noise? Yeah, it does. So you can see that this is perfectly smooth here, blended over 100 frames, so it doesn't even really change for quite some time, right? The frame lag on the lighting change is massive, and all the lighting values are very smooth. I switch to here, and they're complete nonsense. So what's going on, right? Like, what is happening here? Again, let's do the same thing we did before. Let's stuff the values. So assuming that I stuff the values that we're going to send down the lighting pipeline, like so. If I just take average direction out of the equation by saying, all right, let's just look at the emit color. By itself, so we're vaping the average direction to light is just gone. It's always set to point upward. And you can see that just even the emit colors are garbage, right? They're totally wrong. So I guess now what I want to see is I want to see those quad quad indices. Like what's going on, right? So I'm going to actually take a look inside push quad, because it's the only place I can think of now to start to figure out how is it possible that apparently the data that looks absolutely fine is somehow nonetheless ending up completely bogus, and I have no idea how, right? So let's go ahead in there to the place where we actually push it and see what we're pushing. So these vertices, as they come out, I'm just going to look at what they are. All right, there's one. For every quad, these should all be the same, because like I said, right now, in fact, we even have to do on there, it's like these don't need to be per vertex, they can actually be per primitive, which we can do later to just reduce the bandwidth. So if I take a look and I step through here, the light count should always be 4, and it is, and the indices should just climb up nice and smooth like they are. So this is probably just a sprite which has no light indices on it. And yeah, it's a push rect, because only push cubes have this. And this, I mean, it just looks totally fine. Nothing out of the ordinary is happening. So that all seems reasonable, right? And if we look at, I guess I should look at a subsequent frame as well. Like, are those values correct through here? This is all push bitmap, unfortunately. Let's look at push cube. So here we are in push cube. I mean, again, all exactly what you would suspect. Nothing weird is happening here. That I can see anyway. Come into the lighting group. 77 boxes. 1,800 points. Again, everything just looks totally clean here. One, two, 1, 2, 45. So again, that just seems like totally fine, nothing bizarre happening, right? See what we get to by the end here. Oh, come on. I hate that aspect of Visual Studio, how it can't show you variables that were in the previous scope. It's so busted. It used to be able to. I don't want this. So, you know, if I run this for a while, I should see this crawl up towards the full value. And it totally does, right? So that all seems pretty good. Come through here, and we have average selection to light getting zeroed out, right? Could double check that that's plausible. Here's the average direction to light. And it is exactly what you expect. So that all seems totally fine. Then we go through the 77 boxes again. Each one of them should have 24. That all seems fine. Just some basic stats there, and then we go to output lighting textures. We're going to go through all the points again. And again, that all seems really straightforward. You gotta take a look at what these values look like. Those look pretty reasonable, because they should mirror, and they appear to. And then for the Z values there, I'm sorry, the W values there, those should always be stuffed with just the dx value, which we took out of the equation by setting, so it should always be stuffed to 0, right? Because we are stuffing it here, so we don't even have to pay attention to that one. It's not relevant. So that seems like it's the right point information. Light data 1, which should be the color values here. Let me go ahead and take a look at what the emit C0 is. Solution emit C0. I mean, that all looks right to me. So these are the same, so we're sending down exactly the same packed values that we're supposed to be sending down, as far as I can tell. The colors, the positions, and the things all get packed in there properly. So the question is just, how is it possible that this routine gets the right values and our routine doesn't? How does this routine manage to get proper values and the other routine doesn't? I'm so confused right now. Because this routine, I mean, it loops over the boxes, so it is slightly different in that sense, but I have no idea how that could ever actually affect it. I could make the other routine loop over boxes just to validate that fact. I mean, and the other thing we do here is we clamp. And we're not clamping here. So, I mean, I could see if this was a clamping-oriented thing, but we clamp inside the shader. So unless we messed up the clamping inside the shader, I'm not sure how even that wouldn't have an effect, I don't think. So if I were to do something where I said, okay, C equals the clamp of C, right? Yeah, I don't think that should actually have any effect at all on what we're seeing. Yeah, it doesn't. So it's not a clamping problem, right? We're not getting something where the clamping is the primary problem there. What we're seeing is something else, and I don't know what that something else even is. So this doesn't appear to be a problem. It still looks totally fine. So if I was to do this the other way around, again, for absolutely no reason whatsoever, if I just purely decided if I just decided to make this do the loop the other way around, oops. like so, and I will say that shouldn't really be commands lightbox count. That's a bit of a cheating move there, but that's okay for now, I suppose. So here's us outputting these in literally the exact same loop as the one that works. So we have one that outputs them and works and one that outputs them. It's exactly the same loop. So again, completely identical here, only, you know, we've changed the loop structure. Okay, so continuing this absolute absurdity, what if I was to just take the other routine? So this is, you know, we'll just leave this. This is how it's supposed to work. And as far as we know, it should work. So this is probably correct. And we've got a bug somewhere else. If I was to take output lighting points, which at this point I know works properly in terms of outputting the colors, let's just have it output the colors, right? So this is what it draws, and it is drawing it properly. If we go back and look at how that's working, you can see that the only difference here is, you know, we push the full clear on. So, you know, if I didn't push the full clear on, and I just let it do its thing, you can see that in this scenario, right, you have to look at both things on top of each other. But it appears to me, I can even still say, even with all that noise, it's correct. It's still the same thing it was drawing. So the full clear really has nothing to do with it. It's just output lighting points works and output lighting textures doesn't work. So what if I just go ahead and clone output lighting points into making it be output lighting textures, right? So what if I literally take this thing right here, and instead of having it do push quads, what if I just get rid of the full clear, right? And instead of doing a push quad, I'm just going to do this operation. So we literally take exactly the operation we were doing here, exactly the same things that we're pushing on. Okay. So we got this front emit here. So I'm going to take the C and I'm going to make that be equal to the front emit. That's what we were using. I'm going to take the P value and use that as is. I don't care about the D value because we're stuffing that anyway, but let's go ahead and use that. It's fine, doesn't matter. And I'm going to actually just stuff those values, you know, directly in there because I've got them. They're the lighting textures thing here, right? So I'm going to set that to dest. And now we are actually outputting the lighting value from here. And then I'm going to take the call at the end and do the actual push lighting just like the other one did. So now the exact same routine that we were using to get correct results with rendering, I'm going to use. So here is the version that's running through the old one. Here is the version that's running through the new one. And there's absolutely no difference between them, right? So something is super messed up with our sampling, with our pulling from these values. I mean, I don't see any way I could be making a mistake up here now because it's literally doing the exact same operation. And if I draw these directly, I know that they're correct. I can see that they're correct values. So unless I'm really nuts and I'm just missing some really obvious thing that's going on here, this has got to work, right? Because if I flip this to an if one, if I just toggle that, right? Then all of a sudden when I draw this thing, it's right. You know, when I draw these values, they're right. And yet instead, like those are the values that should be interpolated right there. Instead, I just get garbage, like complete nonsense happening. So where is the nonsense coming from? Why am I getting just garbage there, right? Why am I getting totally arbitrary interpolation happening? What did we change? You know, and this has been happening the entire time. So this has nothing to do with the clear change, nothing to do with any of those. This has been happening since we made the initial modification at all. This has been happening. So inside our sum length call or something, you know, this is just working wrong, and I have no idea why. The fragment light values that come in here, where we sample them off of our two lighting textures that we're sending down, those are busted somehow. So let's take a look at what's happening. One thing we did change is way back when we set the render commands up, right? These things here, you know, that was something we changed, and I don't know whether that had anything to do with it. I don't think there's any data from there that we actually send down, but let's make sure. So those lighting texture informations that we send down, those come from the from these right here, this lighting textures value, and that's, oops, coming from right here. So these test textures, it's just a buffer we use. It gets sent down to the render system. It picks it up later when it wants to, right? That's all that happens. So in the OpenGL layer, we have those pieces of lighting information, and they get sent down and transferred. You know, I guess one thing that's a little bit odd there is that actually gets sent down after the first time we render. Is that's one frame lagged, isn't it? Which is kind of a separate problem. I don't think that has anything to do with the bug we're seeing, but it's worth noting that that should really be queued for transfer prior to the actual drawing that occurs. Meaning this is really in the wrong place. Technically, it should be pushed before everything else happens. And, you know, if we were to look at that, I guess the way I would say it is, you know, that call, if we're going to be honest with ourselves, this push lighting here should really not be happening here at all. The push lighting call should actually be occurring like at the head end, right? So when it actually goes to start working with this stuff and we enable the lighting, it should really push the lighting at that point, right? You go, right? Because the two sources, right? And then we fill them in later. So that's actually, how that should be working in order to not have a frame of lag. Again, that should not really change what we're... Okay. Well, I am happy that I fixed the problem. I am not happy because that should not have fixed the problem. Those arrays should have been stable, so when we transferred them should have just resulted in a frame of lag. It should not have changed what we're actually seeing. So I'm not going to consider this okay yet. That's a happy accident, I guess, but something is still wrong here, and we have to go figure out why that did that, because that would imply that we're actually corrupting those arrays or something at some point in the render process so that the lighting information got destroyed. But why? Like, where is that happening? So we have to go... We're not done yet, unfortunately. We found a bug. We fixed that bug. There's still another bug in here, and it just happens that... the fact that we were sending them late was exposing this other bug, and sending them having them push at the right time makes it so that they aren't. But that's not really sufficient. So let's push forward and find out what the bug actually was. Before I do that, though, I'm going to clean out the stuff that was happening here. Because we don't care about this now. So let's see if this works properly now, with everything running as it normally does. So not quite. So this valid part still seems to be problematic for us. And, you know, that makes a little bit of sense, because it may be that since not everyone gets light every frame, we can't really use that fact directly. But here is the lighting as it is, you know, supposed to be running, obviously. And if we see that at actual frame rate, you know, we're in reasonable shape here, right? That looks like the lighting used to look for the most part. So the question here is, why is it that those light values get corrupted on the round trip? What was happening there? Those light values should never be touched by anyone, right? I just don't see where that was coming from. So if you... Oh, man. All right, that is definitely an owl of shame right there. Oh, man, that was brutal. So hopefully everyone realized it at the same time I did, now that we had the happy accident of figuring out that it was because of a frame of lag. So now I know exactly what's happening, and that is pretty baller. So what was happening is that originally, and maybe I should draw this out on the blackboard, but I'm just going to assume that everyone kind of sees it now, but we'll go to the Q&A, and if anyone wants me to draw it out on the blackboard, I'll draw it on the blackboard. So what happened is, originally, we were just assigning IDs persistently, so that when something got a light index assigned, that light index was assigned the same every frame. So, the fact that we were sending down the light data from this frame for use on the next frame was fine, because all of the quads were going to use the same light indices as they would have had the previous frame. Because remember, we were persisting the light indices. When we switch from persisting light indices to persisting light values, it means that every quad potentially gets a different light index every frame. Because it doesn't matter what index it's assigned, they just get assigned linearly in the order they're pushed. So now, sending the light data from a frame behind, right? So using the light data from the previous frame is wrong because all of the quads are looking at different light index positions as to what they were assigned this frame. Because what they were assigned last frame is not what they were assigned this frame. Ergo, they pick up lighting from some totally unrelated quad. I don't know if you guys remember this, but we've talked about this before, and occasionally sometimes people have asked me what are the hardest bugs. I believe you can probably go back to the archives and find me saying something literally that indexes not lining up is one of the biggest bugs that you have that take a long time to find because it's hard to look at them and debug them properly. Well, ladies and gentlemen, guess what? That was literally like an hour of debugging time trying to nail that down. Right? If you take out the time that I went and decided to fix the clearing stuff because I wanted that to be fixed and just look at the other part of it. Well, there you go. All right, so let's go ahead and go to the Q&A. We still got more lighting work to do, but we're over time now. On topic questions, please. So, on the stuff we were doing today. Let's see here. Perhaps the perspective of the game would make this a bit awkward to do, but are you planning to have water in the game with reflections since waves and shaders and all that cool stuff? Or sine waves and shaders and all that cool stuff? No, I don't think we would be doing that. I haven't thought about it too much, but I do think that you're kind of hitting the nail on the head there that spending a lot of time implementing reflections would probably be wasted because it's a lot of work to make reflections work properly in a game. You know, there's a lot of sort of additional rendering work you have to do to kind of get that. You have to render from a different direction and map that directional render onto surfaces and so on and so forth. And so for a game like this that's top down, where it would mostly be water reflecting up at us, I just don't think it's going to be worth it. So we probably wouldn't do that unless there's some other thing that we encounter along the way that makes that more sensible. Oh, Pithno said blackboard, please. So I'm going to draw it on the blackboard. So here's what was happening before, and then I'll show you why it broke. So previously what was happening is we've got light results, okay? That's light data 0, light data 1. That's what gets passed down to the renderer and used. So all of the fussing that we do with raycasting and all that stuff, obviously, all of that is just to produce a single block of data. Well, in our case, we keep it in 2 separate blocks, but it doesn't matter. They could be contiguous. It's just one blob of data that says the position, color, and direction of the lighting information that we're going to use to render the scene once we actually go to make pixels on the screen, right? So all of that lighting result data is the thing that we actually need to compute, and how we compute it is largely irrelevant for purposes of the renderer. The renderer just knows somebody figured this out, and now we're going to use it, right? So what we needed is quads out in the world that need to get rendered have light points on them that have to map into this buffer, right? So each point on the quad that we're going to sample lighting from, because remember, any point in the quad, we draw from a bunch of sample points to figure out what its color should be. So when we draw from these sample points to figure out what color is, we're looking into these light results. And the way that we're doing that is by an index. So there's literally a value that comes with the quad that says, hey, I've got 4 points and they start at point 37 or something, right? If this is light 37. So the shader goes in and looks and goes, okay, from point 37, I'm going to do 4 lights, so 37, 38, 39, and 40 I'm going to look at, and that's what we've got. Okay, very straightforward at that point. Not a lot of weirdness there. That's just all that happens. Now our bug comes from the fact that this particular piece of information, the index, has to get assigned from somewhere. And in the old way, what was happening is that somewhere was getting assigned stably. So every time you did a push cube, it was having a light index storage value, right, that was persisting across those pushes that said where it was. So on frame 0, this quad got these lighting values. On frame 1, it got these lighting values again. On frame 2, it got these lighting values again. The index was the thing that persisted. Now the problem is we know this was only going to be a temporary solution without more work, because once we start moving around the world, we knew that we would have to assign those indexes dynamically, because there's only a certain amount of room in our light result buffer. And so if there's 1 million entities in the world, we can only store, 10,000 of them or 8,000 of them or something. I don't know how many we're going to end up keeping in our local light result buffer, just in terms of processing power wise and storage wise and all that sort of stuff, right? So what has to happen is those light indices had to get allocated dynamically so that when an entity came out of the lighting solution and wasn't needing to be computed lighting-wise anymore, it wouldn't take up space in the lighting solution. However, what I realized was the better way to do that would be just to store the light results themselves back in the entity. So that led to the new way of doing things, which was instead of preserving this light index, we would just say, oh, okay, at the start of the frame, let's go into the entity now and grab the block of results out of the entity. Place that into wherever we want. So as we're just rendering, we just go through and as we encounter entities, we just sort of push them on. So they just kind of get pushed on in any order we want as we render. Grab the block of results, place it in here, perform the lighting computation, and then when we're done, we'll write it back to the entity. So now we don't have to worry about light indices anymore. The light indices of a quad are just arbitrary. Every frame they change, and we just know that the results themselves are mapped back into the correct position, right? And we wrote this perfectly the first time. We did it right. But there was a bug. The bug was that when we were rendering frames, 0, 1, 2, 3, 4, 5, 6, what was actually happening was that on this frame, we would compute light results, we'll call those R, we would compute light results, and then we would use the light results in our actual rendering from the previous frame. That means on frame 0, the lighting was garbage. We just couldn't see it because there was nothing on frame 0. Then on frame 1, what we would do is we would pass, by now, we would get the lighting information from the previous frame. We would compute a new lighting information, right? And then we would render with the previous frame's lighting information, right? Previous, previous. So every frame we were rendering with the previous frame's lighting information. That was because we pushed lighting on at the end of the frame, and that means that when it would read through the render buffer to execute all of the commands, it had already executed all of our render commands before ever updating the lighting textures. So the fix, or let me describe the exact bug first. So the bug is that, hey, the lighting indices aren't stable anymore. It's the results that we're preserving, not the indices. So now, using the previous frame doesn't work. None of the indices line up. All of the entities' quads have moved where they're looking in the light buffer, so they're not looking in the same place they were in the previous frame. That just led to completely random lighting results. It was grabbing lights from all kinds of random places that had nothing to do with where the lighting for this entity was actually stored on this frame. So the only thing we had to do to fix it was to stop doing this. Actually push down the light information we want to use on this frame, and everything's fixed. Does that make sense? What time of the pre-stream? We're not doing a Handmade Hero tomorrow. We're off tomorrow, sorry. So it would be next week. Usually the pre-stream starts around 10 minutes prior to noon, something like that. Valbus. So we have to call the push lighting twice for a solution, or there is another... no, we don't have to call it twice. All we have to do is we just have to push at the beginning of the frame. So... remember, the rendering command buffer is just a buffer of things to do. So we can just push the command that says update the lighting textures as the very first command, which is what we do now. And even though we haven't filled in the lighting information yet, that's okay, because all we're doing is pushing the pointers on that say where to grab it from. Then we're doing all of the other pushes, computing the lighting, and then we're issuing that whole render command buffer out to the renderer. So we don't have to do anything at all to fix the bug other than just move the push call to the beginning. That's it. We don't have to change anything. So it's just fixed now. It's correct. There's nothing else that has to happen, right? That's just what's going on, right? So yeah, no other changes are actually necessary there. And if we go back and look at how we had this before, really this is the only part now that we have to fix, which is the fact that there's a lot of people who don't get lighting on a particular frame, and so that has to be fixed because we can't use those directional values anymore as indication that you don't have lighting. The seltzer. I know you said it's a common class of bug, but do you have any thoughts on how you might avoid a bug like this in the future? Not really. So the only thing I know of that catches bugs like this and makes them easier to debug was a program that I wrote at Rad Game Tools called Mustache, which is designed to figure out complex problems like this. Unfortunately, no debugger that I know of has this capability, so until a program like that becomes more standardly integrated into debugging, I don't know that there is another way if I knew of a better way to keep bugs like this from happening, I would have done it. But the bottom line is sometimes when you're doing finicky stuff like this, you just have a situation where you can't avoid having indices like this, you know? And you try to keep it to a minimum. You know, I don't go introducing indirection willy-nilly. In fact, I try to keep things as direct as possible for this very reason. The more indirection you have, the more places there are for those indirections to be wrong, right? So it's definitely the case that, you know, in general, when I'm programming, I am actively trying to eliminate the places where you can have these kind of bugs. I don't always know of, or there may not always exist, a methodology for a particular class of problems that can get away with, no indices or no sort of frame lag, and so you tend to see this kind of thing happen in complex rendering situations like lighting, where you're doing a lot of what's the word I'm looking for? Where you're doing sort of a lot of complex frame-to-frame correspondence and a lot of things that are using indices and that sort of stuff. You end up in situations where there's not a lot you can really do about it. You're gonna have these bugs, and you just gotta grin and bear it, or grit and bear it, or whatever that phrase is. Valba, so this frame latency is bad if we would make this a multi-thread system? Nope. Really, we're not doing frame latency. We're doing it on the same frame. Are you allowed to elaborate more on how Mustache works exactly? I don't know. So you can't use the 4th lines of light, and on the 6th line the light stops. I'm not sure. Stormblast, I don't understand the question. Can you elaborate on that, maybe? I should go in and, while we're at it, fix that. Other routine. Oops. There we go. So now we can look at our lighting solution, which I wanted to make sure was still possible to do. Okay, is that it for the questions? Do we have any questions on the lighting? What are the performance on the... well, the big level is still problematic performance-wise. I mean, we need to do... We were in the middle of optimizing the lighting, so we... we still have a lot of work to do before we're finished with that optimization. So if we let it create a larger level, it appears like the lighting is fast enough now, but it's not actually, because if you move to some place where more of stuff, like more screens are kind of in that visible set, you can see that the frame rate gets bad, right? So you can kind of see the subset of the region for it's getting computed. So this white area out here is outside the lighting computation boundary. This stuff is inside the lighting computation boundary, so you can see what's getting lit and what's not. And like I said, the lighting is getting there. We have to go in and start the world building process, which is what we'll do right after lighting. And then when points are distributed more evenly across these pieces, then I think we'll get a much better quality of lighting as well. Because right now we're not distributing our lighting points in a sane way. Like we'll, you know, these I think we can get rid of these seams, for example, in a number of ways and so on. But so, you know, it's definitely getting there. It's just we've got to get the speed up, and there's a lot of ways we can do that. And so we're gonna take a look at a couple more things, but that's really where we're at the moment. Stormblasts, can you implement more light sources later? Well, actually, to start with, will you add tone mapping at some point? Probably not tone mapping. I wouldn't expect. We may put a bloom filter in, though. Stormblast, can you implement more light sources later, like holding a torch or other sources light? Actually, right now, that is already happening. So you can add as many light sources as you want. In fact, the little guys are all holding lights right now that are getting fully computed. You can actually see that they're getting the full treatment. You know, you can see, for example, over here where there's a ceiling, you can see the lighting reflecting off the ceiling of those little guys moving around. You can see them lighting up this red wall, et cetera, right? So those are low held light sources. That's why they don't have as much range on the ground as this guy, because this guy's up higher. As you move the light source up higher, it gets a bigger spread, right? So yeah, we already have as many. You can throw as many lights in as you want. This solution doesn't have a fixed number of lights. You can have arbitrary number of lights, and we'll be playing with that later. Not exactly on topic, but you don't use your attempt in the for loop in Splitbox. Oh, we didn't really get a chance to finish debugging that. Or really even... That code is pretty primitive right now. We don't even draw it. So when you say we don't use the attempt... what do you mean? Is it just, do you mean we just don't break out of it properly? Oh, I see what you're saying. Yeah, you're right. So this dim index should actually be cycled, right? And it's not, because next dim index isn't updated. So I think that's actually what should be happening, right? Is that what you meant? I'm not sure if that's what you meant or not. I don't think we'll really see much in the way of results from that, but, you know. Some kind of weird... Oh, you know what that is? So the lighting bounds probably should be based on the camera as well, and right now they're not. So that's a little bit of a bug too, right? Jackson Bannon, what's the difference between the game without OpenGL and with OpenGL? So right now we have not updated the old render path to be the new render style, so we can't really address that yet. That'll be later. All right. Yep, otherwise a useless loop. Yes, okay, so good. That is what you meant there. So I think that's all that we really need to do to take that into account. This routine is still kind of garbage. We have to go through and actually draw our hierarchy. So have you tried the Clang compiler on Windows? The versions of the last few months I've been... I use Clang on Linux and Mac. I have not tried the Windows version in quite some time. The last time I tried it, it wasn't really there yet. Supposedly they've got it outputting PDBs now, but I don't know. I figured there's no rush to using it, so at some point I'll probably switch. That's probably be after my current round of projects, because I don't have any huge problems with the Visual C compiler at the moment. I still use 2012. So next time, instead of updating to a new Visual Studio compiler, I'll probably update to Clang, assuming that no one says it's like busted on Windows, assuming it's, you know, working okay and the PDBs work and stuff. So, because yeah, it would be nice to switch to Clang, because then you could always be on Clang. Because almost everything you ever compile on would be on Clang at that point. Linux, Mac, and Windows would all be on Clang. And I assume, I don't remember what PlayStation 4 was using, but I'm assuming PlayStation 4 used Clang, because I'm not sure what else it would have used. Could have still used GNU, I guess. I'm not sure. At that point, I think the only thing you would have to use Visual Studio for would be like Xbox, maybe. Because Android obviously uses Clang, iOS uses Clang, Mac OS uses Clang, Linux uses Clang. So Windows is the only place you still use Visual Studio. So if you switch that to Clang, you could be Clang everywhere. And the only place you might have to use something other than Clang would be like Xbox. Because I assume, I've never done any Xbox One development. But I assume that the Xbox One is currently using Visual Studio's toolchain, but I don't know. And yeah, to your point specifically, I do agree the Clang compiler gives much better error messages, especially if you're someone who's like doing, you know, sort of more C++ heavy stuff, which I don't really like. But if you're the kind of person who uses like templates and stuff all over the place, you know, the template error messages in Visual Studio have historically been quite bad, and it makes it pretty hard to debug template code errors, whereas Clang does a much better job, from what I remember anyway, in code bases that are like template happy, of actually giving you actionable error messages instead of going, okay, that really didn't tell me what I need to know. I got to kind of guess myself about what happened wrong in the template expansions. You know, Clang, if I remember correctly, was pretty good about saying, here is where in the template stream of things stuff went wrong. And that was nice. So, all right, I'm going to go close it down. Okay, thank you everyone for joining me for the episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along with the series at home, you can always pre-order the game on handmadehero.org, and it comes with the source code that you can use to play around with yourself and experiment. We also have a schedule bot you can use if you want to know when we're going to be live. I know that was a question today. The schedule bot will tell you in the posted schedule. There is a bit of a snafu I'm updating the Molly Rocket websites this month, rolling them over to all new systems and stuff, and they're kind of going on to a CDN, which means that the place where these tools get their information from as far as the schedule is a little wonky. So the schedule bot is always up to date, but the information on some of the other utilities like InsoBot, I think, on the web, and also this little guy here are currently perhaps a little bit iffy. So that will be getting straightened out, but if you're wondering why there's been some issues with that, it's because there's going to be a web migration and some of the things cannot be done the way that they used to be. So I will be working with people like the folks who maintain InsoBot and so on to make sure that they can get stuff from the correct new locations. But until then, yeah, ScheduleBot is the place to look if you want to know what the schedule is. All right, we'll be back next week. There is no Handmade Hero tomorrow. It's a day off. We'll be back next week when we can resume our lighting optimizations, and we'll be playing around with that spatial hierarchy and the update loop to try and get to something nice and fast. And we'll also be probably introducing our skylighting into there as well. So we've got some work to do. That'll be fun, and we'll be able to improve the lighting quality a bit, I think, as well. So that'll be good. That's it for this week. Until next week, have fun programming, and I'll see everyone on the internet. Take it easy, everybody.